Complex embedded systems consist of many components that work together. ECUs, sensors, controllers, and actuators are all connected, and they usually communicate over bus systems. As a system tester, you need to know some basic knowledge about bus systems. The buses where signals travel, where timing lives, and where a surprising number of defects can happen. So let's look at the different types of bus systems. You have CAN, which is the most widely used bus in automotive and industrial systems. Basically, you have two wires, a multi-Mauser setup, and a collision resolution. Classic CAN runs up to a megabit per second, but CAN FD goes up to 8 megabits with a 64-byte payload. LIN, on the other hand, is single wire and follows master-slave principle, and it is limited to 20 kilobits. So this is built for low cost and non-critical functions. Automotive Ethernet carries the high bandwidth applications like cameras, radar, over-the-air updates, etc. It runs on a single twisted pair with some IP for service communication and DOIP for diagnostics. FlexRay is deterministic and time-triggered, which is built for steer-by-wire or brake-by-wire, where safety and guaranteed timing is a non-negotiable. It is declining in the recent years, but you will still encounter it in existing systems. System test usually does not test the bus protocol itself, which is a job of lower level testing. But what a system test does is to validate the end-to-end behavior using the bus as a medium. So, for example, you answer questions like, is the message content correct for the given system state? Are messages sent at the right cycle time with acceptable latency? Or does diagnostic communication work properly? Coming to the test infrastructure. So every bus test setup needs a network database where the messages are defined. It's a DBC for CAN, LDF for LIN, RDR XML for Ethernet, and FlexRay. So this information is important, for example, to simulate messages or to analyze messages. Let's have a look on the different tools that you can use for that. For passive capturing, use Canalizer, PCANView, or Wireshark. For active simulation, you have CANRE or CAPL scripts. There are some important points to take into account when handling bus systems. So database version mismatches are a common failure in the test setup. Also, when it comes to timing violations, it is important to do a proper stress test, as they are often intermittent. In mixed bus systems, the gateway is a critical test target to make sure that routing and protocol conversions between bus systems are working properly. And if your bench is missing some nodes, you have to simulate them correctly. An incomplete simulation produces false passes or leads to a flaky system. So to summarize, bus systems are kind of the nervous system of embedded complex systems. It is important to have some basic knowledge to handle them.